Alright, hi Year 11s, this is Mr. Lim here, and this is our second video on materials and separation techniques about nanomaterials. Woo! So, what are nanomaterials? We're going to find out, and what they do. Alright, so nanomaterials are defined as substances with particles within the 10 to 100 nanometer ranges in size. So you need to remember or memorize that definition of what their size is. What is a nanometer? 1 nanometer is 1 times 10 to the negative 9 meters, which is 0.00000001 meters. I don't know if I said enough right zeros there, which is equal to very small, right? Really small stuff. For example, a water particle by itself is 0.3 of a nanometer. One carbon dioxide particle is 0.33 of a nanometer, right? Are water particles and carbon dioxide particles nanomaterials then? No, because they are too small, right, for them to be nanomaterials, because you've got to be within the 10 to 100 nanometer range of sizes. All right. Why are nanomaterials so special? Because they have different properties at the nanometer scale compared to their bulk size, which is their normal size, right? And because we haven't turned everything into nanoscale yet, it's kind of cool to find out what kinds of cool properties things have at their very, very small size scale. So gold at bulk size is yellow, but gold particles at various nano sizes can be seen as different colors and used in stained glass windows. So that's how, well, some of the colors in stained glass windows are made from powdering gold to the point where they are nano size, and therefore they change their properties and they can make stuff look fancy. All right, but in general, we study nanomaterials because they have different properties from their bulk materials, and if they have different properties, they can be used in different ways because they're kind of fancy that way. All right. The only problem is that, like in health products, so if you're using them in health products such as zinc and titanium oxides in sunscreen, so zinc and titanium oxides are what makes your sunscreen kind of sparkly now. If you notice that, well, actually, you guys are all very young, but way back in my day, sunscreens used to be a lot more thicker, and they used to be a lot more white, so it would be a lot easier to see when people had sunscreened up. But now even your highest rating sunscreens are very transparent because they've got nanoparticles of zinc and titanium oxides in there, and those nanoparticles are A, transparent, and B, they do still block out lots of UV light, which protects your skin and blah blah blah, which is good, right? However, their use in health products has to be monitored very closely because the size of the particles means that they could theoretically enter cells and have various effects, which means that they have to be studied for a longer period of time until people feel that they're super safe. But, well, that's the way of everything. All right, and that's it for nanomaterials. Adios.